This is Algebra 2B, Probability Lesson 4, Addition Rule. The addition rule for probability states the probability of A or B is equal to the probability of A plus the probability of B, but sometimes those two events may overlap, so we also need to subtract the probability of A and B. Now, sometimes events overlap. So you can kind of even preview in this first example. You can be a math student, like if you're in math first hour. Then you could be a science student, like if you're in science second hour. Or you could not have math and science anywhere in your day. Or you could have just one, just the other. So sometimes there's an overlap, sometimes there's not. Mutually exclusive means that there is no overlap. The probability of A and B is 0, okay? So if the probability of A and B is 0, you can just go ahead and add A and B, because if you're subtracting 0, it's not going to change anything at the back. Okay? So, to clarify, to reiterate, the probability of A and B is 0. If two events are mutually exclusive, it means they cannot happen at the same time. So if you want the probability of A or B, you need to add their probabilities together and subtract any overlap if it exists. That's our formulas. Let's try. Example A. Of the 100 students in 12th grade, 70 are enrolled in mathematics, 50 in science, 30 in both, 10 in neither. Let's fill out this Venn diagram here. So I'm going to put a big M over here to show that that circle represents the math circle. I'm going to put an S over here for the science circle. When my problem tells me that there's 70 students in math, that means this whole circle is going to have 70, okay? But I'm not going to throw a 70 here because whatever I got in each region is going to have to add up to 70, okay? So, what I really need to start with is the and, okay? There is 30 in both subjects, so because I know this whole circle needs to be 70, if I already have 30 in that circle, it means I'm going to have 40 in this region. So there are 30 students in both math and science, 40 students who are not in science but in math, which makes 70 altogether. I'm going to do the same thing for the science circle. I know that there has to be 50 in the whole circle. I already have 30 in that circle, so that means there's going to be 20 more in this region of the circle, okay? 30 students who are in math and science, 20 who are in science but not math. And the last piece is students in neither subject. I'm going to throw him in the corner. There are 10 students who are outside of those circles. And if we check, I do know that I'm supposed to have 100 students. So 40, 50, 60, 70, 80, 90, that's 100 altogether. Find each probability. Math. There are 70 students in math out of the 100 students. So we can give that a decimal or a percent if we want. Science, there are 50 out of 100 in science. So again, we can give that a decimal if we want to. Math and science. The and is that region in the middle, okay? So this is our and. There are 30 students in math and science. So I'm going to give that a 0.3. And last, find the probability of math or science. Now this is our formula. If I just added up math, 0.7, plus science, 0.5, if I added those together, that's 1.2. And I know probability can't go higher than 1, right? I can't have 120% of students. That's why I need to subtract the overlap. If I add up the 70% of math plus the 50% in science, I just double counted that 30% in the middle. So using my formula, that's going to be 0.7 plus 0.5. but also subtract off the 30% in the middle that got double counted, okay? Let's make him look a little neater. 0.7 plus 0.5 is 1.2 minus 0.3 gives me a 0.9. Now that's not the only way to get this answer. I just wanted to show you how we use that formula. We could have just added the three values inside 40 and 30 and 20. That's also a 0.9. We could have also used our complement. Math or science would be not this guy, right? So if I have 10% outside the circle, that would leave me with 90% to get to 100% altogether inside those regions, okay? So 0.9 or 90% are in math or science. Example B, suppose a card is drawn from a standard deck of playing cards. Find each probability. Yeah, I think I want to put this on another page to make it easier. Okay, so I got my sample space on another page. Is he frozen? There we go. So that I can just click back and forth. So first one says probability of heart or face. Okay, back to my sample space. I have my hearts here. There are 13 hearts out of the 52 cards. And then my faces are my JQK. So here are my faces. And there are 12 faces. But notice I double counted 3 here. 1, 2, 3. So I'm going to add up my hearts plus add up my faces, but then also subtract the overlap. Okay? So back here, hearts. That is 13 out of 52. Faces. That is 12 out of 52. Overlap. That is 3 out of 52. I'm purposely keeping these unreduced because with fractions, it's much easier to have a common denominator because I can go straight across the top and keep the denominator the same. So 13 plus 12 is 25, minus 3 is 22. Now, if we wanted to, we could reduce that fraction or get a decimal, and that would be, oops, I wanted the decimal, 42%. Okay. Ace or red. Let's go back to our sample space. Ace or red. Okay. Aces. I have 4 aces across the bottom here. And I already forgot what it said. Ace or red. And if I'm looking at my reds, I have 26 reds here. But notice how I just double counted the 2 red aces. So using the formula, there we go. Using the formula, there are 4 aces in my 52, plus there are 26 reds in my 52, but there are 2 red aces, so I don't want to double count them. And that's going to give me 28 in the numerator, denominator no change. And if we wanted to get that as a percent, that's approximately 54%. Letter C, 7 or king. 7 or king. Back to my sample space so that we can illustrate this. 7 or king. I have 4 sevens and I have 4 kings. Notice that these do not overlap. Those are mutually exclusive events. You can't be a 7 and a king. So all you have to do is add them together. There's no subtraction piece to this mutually exclusive problem. So there are 4 7s and 4 kings. These are mutually exclusive, so I do not need to subtract any overlap. And 8 out of 52 is approximately 15%. Odd or black? Odd. Okay. Odds. That's going to be 4 here, 4, 4, 4. Letters can't be odd, right? Okay. 4, 8, 12, 16. Blacks. Blacks are going to be here. So notice we double counted 2, 4, 6, 8. Okay? Using our formula then, that gives us 16 that were odd, 26 that are black, but 8 of our odds are also black, so we subtract off that overlap. Make sure I count it right. 4, 8, 12, 16, 2, 4, 6, 8. Yeah, looks good. So that is 34 out of 52. Which is approximately 65% chance. Oh my God, there's another one. Okay. Example C. There's a lot of them. The Venn diagram illustrates students' preference for skiing or snowboarding. Find each probability. The probability of S, which stands for skiing. Okay, so our skiing circle is here. So remember, we need to add those two regions together to get the complete skiing circle. So that's 39 and 7, which gives me 46. Because I'm looking for a probability, I also need to know out of how many students altogether. So I'm going to also add the 15 and the 4. That gives me 65 students altogether. So 46 in the ski circle out of the 65 students altogether. And let's go to a decimal just for fun. That is approximately 71%. What is the probability that someone likes snowboarding? Here is our boarding circle. We're going to add the two regions in that circle. 9 and 15. It gives us 24. It's still out of 65. So 24 out of 65 is approximately 37%. How many students like skiing and snowboarding? The and is in the middle there, so he's actually a little less work because we already have our 9 and our 65. 9 out of 65 is approximately 14%. And finally, skiing or snowboarding. There are, again, 3 ways to figure this out. I'm going to follow the formula tactic, and that's skiing plus boarding minus the overlap, okay? So I'm going to go 0.71 plus 0.37 minus 0.14. Looks like 94%. Now, that didn't have to be the only model. We could have also added all 3 regions together or subtracted all 3, subtracted our complement, right? So we could have done 61 out of 65, or 37 plus 9 plus 15 should also be 61. 3 different ways to get that answer. And is that it? Hoofda. Good luck on the exercises. Please let me know if you have any questions.